Hello YouTube, SentinalhMC here for episode 7 of my RotaryCraft tutorial series. We gotta get started right away this episode because there's a lot to talk about with gas engines, because I want to get through everything to do with gas engines in one video. So yeah, we're talking about the gasoline engine and the performance engine, both of which run on ethanol. So it's the first engine that we've talked about that actually runs on a fuel source that you have to produce, because honestly the hydrokinetic engine, I mean, it takes lubricant, but it's not really using it as fuel per se. I mean, it says it is, but it's kind of not the same thing. So this is the first fuel that has takes multiple products to produce. So first let's talk about how to produce ethanol. And if you hear any bloops in the background, that's not you, it's in the background on my end. So anyway, to produce ethanol you need a fermenter, which is crafted really simply with 4 steel ingots, 4 base panels, and an impeller, and that gets you the fermenter. So the fermenter, it needs a water source, so let's put it in here because you have to put power in the back, so you can't put water that way. Now the way the fermenter works, if we go into its inventory, this is the water tank here. It holds 4 buckets of water at a time. It's got a temperature gauge. These are for our 2 inputs, and this is for our output, and this tells you what product we're going to be making. So temperature, first of all. The fermenter is temperature sensitive. It likes to operate in temperatures of around 25 C. If I put it over here in the desert, you'll notice this thermometer is now in the orange, and it's going to run a lot slower, or it might not run at all. If you must use it in a desert, you can put a block of water underneath it, and that'll help cool it off, but you're best off just doing it in a biome that's between 20 and 30 degrees C. So the first thing we need to produce to make ethanol is yeast, and that's produced quite simply with sugar and dirt. So sugar, of course, made from sugar cane, goes in the top slot, and dirt goes in the bottom. And then we power it, and all this takes is a DC engine because this requires very little power. So yeah, power it with a DC engine. And it runs very quickly to produce yeast, so a DC engine is all you need. I mean, I see no reason to put any other power source on this. So we'll grab our yeast, we'll make it stop. Yeah, the GUI seems to glitch out on the fermenter. So we've got 11 yeast. Now we need to use this to produce sludge, which I already have some over here. And the way that we do that is with the same machine, but we have to change this target. And the way you can do that is by putting a lever on it, or just feeding it a redstone signal in general, and that'll switch it over to sludge mode. So when it's receiving a redstone signal, it's in sludge mode. When it's not receiving a redstone signal, it's in yeast mode. So now it's in sludge mode, we have to put some resources in it. The yeast, it goes in the top. And then you have to feed it some biomass in the form of saplings or leaves. If you feed it a sapling of any type, you'll get 1 piece of sludge. If you feed it a regular leaf block, you get 2. So I highly recommend making some shears, gathering leaves, and using them instead of saplings, because they produce twice as much for the same amount of yeast. But if you have Twilight Forest installed, you have access to canopy tree leaves. And for every canopy tree leaf, you actually get 6 sludge, and I don't know why this is the amount of this jumping around. The fermenter, the GUI is a little bit buggy, from what I've noticed, at least in my version. I don't know how it is, and maybe it's probably been fixed by now. But yeah, it produces 6 sludge for every canopy tree leaf, so I highly suggest going to the Twilight Forest, getting some saplings of this tree, grabbing some leaves, and using them if you have that mod installed. Alright, and the best way to automate this is to probably make 2 of these, set one of them to produce sludge, and then you just have the yeast coming out of this one, going into this one, and feed it with leaves or saplings, and it'll make sludge for you. And then to turn the sludge into ethanol, you just stick it into a furnace, and that gives you ethanol crystals. So I've got 3 ethanol crystals. And now we have ethanol. So we now have fuel for our 2 gasoline engines. So let's take a look at how to make them. A gasoline engine is crafted with 2 base panels, an impeller, a shaft unit, a 2X gear unit, a gold ingot, 2 cylinders, and an ignition unit. So the cylinders are crafted quite simply with 8 steel ingots like a chest, and you get 2 cylinders, which is enough to make 1 engine, so that's really nice. And the ignition unit is crafted simply with 5 steel ingots, a piece of redstone, and either 2 electrum or 2 gold. So if you don't have thermal expansion, if you don't have electrum, you use gold. If you have access to electrum, and you probably want to use that because it's cheaper than using gold, really. But either of those work, gold or electrum, to get the ignition unit. Then just put them all together like so, with the ignition unit on the left, 2 cylinders, and that'll give you the gasoline engine. But hang on. Basically, what I'm going to tell you now is that I don't see a reason to make this gasoline engine, because the performance engine is just so much better than the gasoline engine. It's not much more expensive, doesn't require any additional fuel or anything. It's better. It's flat out better. So I would highly recommend making a performance engine. I mean, if you just don't have a supply of water, I guess you wouldn't want to make the performance engine because it needs one. But I mean, when are you not going to have a water source in Minecraft? But the performance engine is exactly the same recipe as the gasoline engine, except for one part. It requires a radiator instead of a bar of gold, and the radiator is created with 3 steel ingots, 3 liquid pipes, and 3 gold ingots. So I mean, it's definitely more expensive, but it's not prohibitively more expensive. It's just a little bit more expensive with some liquid pipes and some extra gold. So I mean, it's a really good deal. I would recommend just making this. But now we have both. Let's go ahead and place them down so you can see what they look like. And I've got this area set up for them. So you can see the gas engine. It looks pretty nice. Looks like an engine, like a, it's a V6 apparently, or something. I don't know. And V12. I don't know. Probably each one of these. I have no idea about engines, guys. But here we have the performance engine. You'll notice that it's connected to the liquid pipe at the back. You have to feed water in through the back. It will not go in on any other side. I have tried it. And yeah, if you want to get one of these going, just give it ethanol. It starts turning. And this is the fuel gauge, and if you mouse over it, it'll tell you how long, exactly how long it'll be running, which is a really nice touch. So if I stick a dyno on this, you can see what the power output of the gas engine is. It's 65 kilowatts at 128 newton meters of torque and 512 radians per second, which is quite good. Compared to the steam engine, it's basically the engine that's one step above it as far as power output goes. It's quite nice. You'll notice it produces 128 newton meters of torque, so you could run a grinder off of this straight up if you wanted to. I have done that in the past, although maybe a little bit of a waste. But you can do it to get your first bit of lubricant if you don't want to wait as long as it'll take for one of these to do it. But anyway, 65 kilowatts. And now let me set this up here. So you can put your ethanol in 2 ways. You can obviously put the crystals straight into these engines. Now this is running. And you'll notice it produces the same amount of power. The same amount of power as the gas engine. So you're probably wondering what the point of this thing is, but we'll get to that in a second. Yeah, you see where it goes. You can put the crystals straight in, or you can melt the crystals down into liquid, and you can pipe that liquid around. If I take a bucket and right-click on one of these engines, I'll pull a bucket of ethanol out of it. So for every ethanol crystal you put in, you're putting in 1,000 millibuckets, and one ethanol bucket holds 4,000 millibuckets. And of course, this can be stored in reservoirs. I got a reservoir here, and then you can use fuel lines to pipe that stuff around. So a fuel line is crafted with 3 glass and 6 obsidian in a work table. It gives you 16 fuel lines, so I mean, you do need obsidian for it. But the fuel lines, if I grab these fuel lines out of here, will allow you to pipe fuel into these 2. And you need to pipe it in from the bottom. It's the only way it works. So you take a reservoir, and this magic wand is a creative tool that will allow me just to make this an infinite reservoir. So that's all that is, so don't worry about that. So now that you can just pipe liquid ethanol straight in. And the way that I like to melt the crystals into ethanol in my single player is to use a magma crucible from thermal expansion, but you know, there's probably other ways to do it. I'm not really sure, because that's the way I've done it. So now, why is the performance engine better than the gas engine? Well, it's because of this tank right here, this side. And what that side is for additives, and I don't seem to have any, so let me grab the additives. The 3 additives you can put into this engine are redstone, gunpowder, and blaze powder. And they all do the same thing. Each one of these is going to increase the amount of power that this thing outputs. So if I drop a stack of redstone dust in this engine, it fills the gauge up about a quarter of the way, and we're now producing 262 kilowatts at 256 newton meters of torque at 1 kilorad. So what we're doing is we're producing the same amount of power. We're producing a quarter of a megawatt, which is half of the power produced by a hydrokinetic engine with a giant waterfall over it, 64 blocks. But we're doing it with just a 1-block little engine that you can pick up and move somewhere else and do whatever you want with it, which is quite nice. Now, all 3 of these additives do the same exact thing as each other. They don't produce any additional power, but what they do, if I just break this to empty the tank there, remember that the redstone only filled this by a quarter. If we add gunpowder in here, already you can see it's going to fill it halfway, or maybe a little bit more than halfway. I'm not really quite. It looks about half. So gunpowder, it's twice as good as redstone. It lasts twice as long. And if I chuck blaze powder in here, notice that it only took less than half the stack to fill it the remaining way. If you put blaze powder in this thing, 1 stack of blaze powder is enough to totally fill this up. So they just last longer. Blaze powder lasts twice as long as gunpowder and 4 times as long as redstone. So just decide whatever resource you can get yourself together a lot of, whatever one you can produce. Maybe use a mob grinder to produce gunpowder, or if you have a blaze spawner, you could get blaze powder. However you want to do it, that's the ratios. The blaze powder lasts longest, the gunpowder is the middle range, and the redstone doesn't last very long at all. It's not very good. So what are we going to do with this the gas engine? Well, what I like to do with gas engines is I like to power an extractor. The extractor is RotaryCraft's ore processing, which is probably why I called it the processor in the last video, which was a mistake. So the pulverizer from thermal expansion, the macerator from RotaryCraft, those things double your ore output, but the extractor can quintuple your ores. It can give you 5 ingots per ore block, which makes it the best, the most efficient as far as ore to ingot output of any of the machines that I've used. So this is really, really, really good. I mean, if all you want to do in RotaryCraft is use the extractor, I wouldn't blame you, because this thing is seriously good. It's crafted with a block of netherrack, a shaft unit, a base panel, some smooth stone, an impeller, a drill, 2 steel ingots, and an oak wood plank. And the drill is crafted simply like this, with 7 steel ingots in a drill shape, gets you the drill. Now, the processor, I keep saying the processor, I don't know why. The extractor is quite nice, but it does have some interesting power requirements, and it works in interesting ways. So first of all, you have to put power in from underneath the extractor. So I'm just going to go ahead and I'm going to set up a bevel gear here, because I'm going to power it off this gas engine. Pop it down, and then the extractor needs a water supply. So let me just grab some of these liquid pipes, and you can pump the water in from any side. Let's give this a water supply. Very good. So this is the extractor's GUI, and it might look a little complicated, but it's not really all that. It's really not that complicated. You just put the iron ore up here, and it starts working. So let's put the iron ore up here. You'll notice, however, it doesn't work right now. It's not working. Why isn't it working? Well, we have enough power for all 4 stages. See, this is stage 1, stage 2, stage 3, and stage 4. We have enough power for each of those, but we only have enough speed for the first and the last stage. But right now we have enough torque for the center stages, but not for the first or the last. So what do we have to do? We're going to need to use a gearbox. And the gearbox that you'll need to use in this situation is a 16:1 gearbox. So I'm just going to place a bedrock one so I don't have to worry about lubricant. Let me just set this up again. Put the extractor back. Give it a liquid water supply. And now if we look at this, we suddenly have enough power, speed, and torque to run the first stage and the last stage. So if you're going to power this with a gas engine, 16 gearbox. So if you go to the handbook, you can see the exact amounts of power that this thing requires for each stage. So it requires the most power for the first and last stage. It requires the most torque for the first stage, and then half that torque for the last stage, and it requires a crap ton of speed for the second and especially the third stage. Now you can power this constantly without needing to swap it. If you're able to produce 512 Newton meters at 8192 radians per second, this thing will run constantly all 4 stages without having to do anything. But that's going to require like a lot of power, like something like the hydrokinetic engine, which is still going to need gearboxes because it has no torque. So, but anyway, let's keep on topic because there's a lot to go on through still. So now that I've got this 16:1 gearbox on here, if I stick the iron ore up at the top, well, you'll see that this will start running. So the first thing the extractor does is it grinds the iron ore. That's what the drill icon is, and it'll grind the ore into dust, and that'll be done in a second here. You'll see that it's taking quite a while. It doesn't tell you what the operational speed is, probably because it has so many stages, and these stages run at different speeds. And you'll see that in a second. Come on. There we go. So now we have some iron ore dust. But stage 2 isn't running because we don't have enough speed. But if we take our screwdriver and we switch our gearbox into speed mode, now the second stage is running and the first one is stopped. I mean, you'll see that this doubled our ore already. We got 2 dusts for 1 ore, but now we just got 2 of the slurries, which is the next third stage, for each dust. So we just got doubled again. And now this slurry gets turned into iron ore solution. Now, it won't always double at each stage, but it does it often enough that it averages out to about 5 ingots worth per ore block. That's the average. So if you run 100 iron ore blocks through, you know, your chances are you're going to have gotten an average of 500 ingots out, or somewhere around there. So now we've got our iron ore solution, and we've got 5 of it. So that's pretty darn good out of 1 ore block. Well, actually, we processed... No, I started with 63. We processed 1 ore block. So now if we take our screwdriver and swap it back into torque mode, we'll start running both the first and the last phases. So the way I like to do this is I like to run a bunch of ore until I get a bunch of solution. And then I like to alternate between the two. If I'm trying to produce to finish this off, the solution, and get the flakes, which is the next thing we get, I like to make sure I've got some ore over here so that I'm not wasting that production. Because while this is going, I could be grinding some ores. So, you know, this is the slowest part over here. This thing tends to run faster than this. So now we've got iron ore flake. So we get 1 flake out of that first piece of solution, and then you just take the flakes, stick it in a furnace, and you get an ingot. There you go. So if we let this run, we would get a lot of stuff. Now, it can make your storage a bit cramped if you're constantly churning through ore and you don't finish it all the way, because the ore dust and the slurries and the solutions have no other purpose than to be run through the extractor. So you can end up adding a lot of extra items that you're gonna have to store in a lot of chests. But anyway, and you can also get some extra stuff, like we just got 2 flakes out of 1 solution, and we got some aluminum powder too, which is great. So it's really nice. You can get extra materials, and you can get up to an average of 5 ingots per ore, which is great. I've already got 3 ingots, and we haven't even gone through all the solution that I got from 1 ore block. So that's why the extractor is really, really powerful. It's really, really good. It's the best, in my opinion. You know, it's the best ore processing machine in the game. Now let's talk about one more thing. There's one more thing we need to talk about when it comes to these gas-powered engines, and that's the engine control unit. So I'm sorry if this episode is dragging on a bit long. like the last one did. The engine control unit is crafted with 6 steel ingots, a piece of redstone, either electrum or gold, and a circuit board, which we learned how to make back when we made the dynos. And that gets you the engine control unit. Now, what is the engine control unit? Well, what the engine control unit does is you place it underneath your engines. So I'm going to go ahead and I'm going to break this. I'm going to place it down there. And the engine control unit has its own tank, its own internal storage tank for ethanol, and it can pass the ethanol onto the engine, which is quite nice. But what this does is it modifies how the engine runs. It's able to change, and why isn't this getting any extra fuel? I have no idea. But it can change the operation of the engine, and when we do that with a lever, for example, right now, as long as these 2 engines have fuel, they will run. Well, and I can't even see it. If I put a lever on the engine control unit and I give it a bash, this should stop running. Oh, wait, let me see. Screwdriver set to 0, 0. Oh, shift. Now redstone operated. Okay, so when you place your controller, hold shift and whack it with a screwdriver. And then, come on. There we go. So, notice how this isn't ticking down anymore. That means that this engine is turned off. Now, it's still turning, which is a bit concerning. Maybe this engine's a bit bugged, I don't know. But, you can turn the engine off, so it no longer consumes fuel, which is great. So, I'd highly recommend making one. It's not that expensive. Let me slop the dynamometer back on there. Yeah, the power is winding down, so, and now it's off. Now it's done, so it's stopped. So that's what the engine control unit does. But you can also do a couple of other things. So let me go ahead and pop a dyno here, and then I'm going to put some shafts across this just so I can actually see what's going on, and hit the lever, I should say. So let me just use steel shafts, doesn't matter. So if I turn this on, we're back to producing 262 kilowatts. But if I take the screwdriver and I whack... Well, actually, wait. How does this work? Do I just hit it with an open hand? Come on. I know this works. Okay, I swapped it back into manual control mode. Why isn't it working right? Screwdriver. There we go. Okay, so what this does is, I just set it to 6.25% speed. What the engine control unit can do is it can throttle down your engines. It can throttle down the speed of the engine at the same torque, which reduces the power output accordingly. But here's the thing. The slower the engine runs, the slower it consumes fuel. And this, apparently, the fuel gauge appears to be bugged out on this engine. But the slower it runs, the less fuel it consumes. So if you wanted to, I don't know why you'd want to do it to this extreme, but if you wanted to be able to produce 256 Newton meters of torque with a gas engine and you only needed 16 kilowatts, I don't know when that would happen, but if you did, you could use this and throttle it down. But the basic gist of this is that the engine control unit, it lets you turn them on and off, and it lets you change their speed. So if I give this a whack, now we turn it up to 25% speed, it's now producing the same amount of power as our other gas engine is, but at twice the torque, but half the speed. That's 25%, and it'll run through its fuel a lot slower than this does. Apparently, this number readout doesn't quite work when we use the control unit. So let's grab an angle transducer. Nope, doesn't work. So it doesn't accurately report how much fuel it has remaining when you're using it, but trust me, it does use up the fuel slower. We can whack it into 50% speed, and it's always the same thing. It'll just keep adjusting the speed of it, and you can use it to conserve your fuel. But what I tend to do is just leave it in redstone mode and just use it to turn the thing on and off. No. Let's set this back to 0, then set it to redstone. So the way that works is whatever speed you set the control unit to in manual mode, when you swap it over into redstone mode, the mode will be either completely off, or whatever that percentage was, or all the way on. So I really hope that didn't confuse you. If it did, ask in the comments and I'll help clarify. But basically, that's the engine control unit. It's pretty useful. Even if the only thing you want to do is turn off your engine when you, so that you don't consume fuel, it's a great use for it. So yeah, those are the gas engines, guys. I feel like I have confused myself this episode. Let's smelt up the rest of this iron and see what we got. Remember, we only processed 1 iron ore block, because I started with 63, because I was testing it earlier. Wow. 8. So yeah, that is ridiculous. That is a ridiculous amount of iron ingots to get out of like 1 iron ore block, but that's the power of the extractor. But of course, with great power comes great power requirements. You need a lot of power to power this, a lot of torque, so you need a 16 gearbox and a gas engine, which is the easiest way I've found to power this thing. So I hope you've enjoyed this episode. I hope you've learned a lot. I hope it hasn't been too confusing. I mean, I felt a little rushed, but I didn't want this episode to be ridiculously long. It's probably going to be anyway. But I hope you enjoyed this episode. Obviously, any questions you still have or confusions, ask me in the comments, and I will answer your questions. I hope you've learned from this episode, and we'll be able to go forth and use the gas engines and use the extractor with like a pro. I'll see you in the next episode, in which we'll talk about something. I haven't quite decided yet, but I'll tell you in the description later when I've figured it out. But anyway, I'm SentinalH, and I'm signing out.